Right, everyone, if you want to get sat down for the very last lecture of ESS 21. I asked my other class if they were excited or sad, and I think both was the response. Okay, so quieten down now, please. So our theme for this week has been sea level rise, the fact that we can see that as our climate warms, it really shouldn't be a shock to anyone that with the melting of a lot of the ice on our planet, we are going to see sea level rise. Also, just the expansion in because our ocean is warming, is going to result in sea level rise. And so for the last lecture today, we're moving a little bit away from ice to really think about the consequences of that for the rest of the world. Because that is something that may be happening up in Greenland, a very long way from here, but it is going to have direct consequences on a huge part of our population, even here in Southern California. So as a reminder, if you need a last quiz score, then quiz 10 will be available from 3 p.m. today until 2 p.m. on Monday as normal. So if you have 8 perfect scores already, good for you, that's great. But if you would like a chance to practice using some of the ideas we've learned about this week, then this is also available for you. So, boring admin stuff to get out of the way. The final evaluation is up. I would really appreciate it if you could take a couple of minutes to fill it in, because I really do value any comments or suggestions you have about how the class could be improved. And also remember, if you need another day's worth of iClicker points, then the survey is available again until Sunday night. And even if you have all your iClicker points, if you want to help us out and help us learn a bit more about the science literacy of the students here, then we would very much appreciate your help with that. Other stuff, there will be a final review session, and it will be in here, conveniently enough, from 1:30 to 3 p.m. on Wednesday. So the TAs will be running that, so please do bring your questions for them. Other sort of stuff is our participation grades. I will post those on Sunday night once that last survey closes. All remaining extra credit assignments are also due by midnight on Sunday, and so if you haven't had the chance to submit or send your extra credit, then please do that. I have so much to grade right now, it's not even funny, and so please do be patient with me. Your scores will appear over the weekend and in the early days of next week. If you haven't seen your score appear by sort of late Wednesday, Thursday, please do send me an email and check up on me. Also, remember there are no regrades after the final, so please, if you have had a look through your midterm and think that we've made an arithmetic error or you can't understand why we took a point off, then please do see us before the midterms, before the final, because there's nothing we can do after that. So any questions about that stuff? Yes?
It says ELH 100. This is EH 100.
Oh, sorry, I'm getting my... That is definitely the right room, and that's
over there.
Okay, so it's not this room, it's over there. Thank you very much for that. It's my sleep deprivation. So it's not this room, but it's the one just across the ring road there, okay? So I'll confirm that with you. So our final is a week today, so there's still plenty of time to study. It will be from 1:30 to 3:30, so do note the change. It's not 2 p.m. like our normal class time, it's half an hour earlier. And do make sure that you arrive in plenty of time to find your seat. It's going to be the same format as the midterms, but it's going to be longer because we have longer, gives you a chance to show me what you know. So you'll need a Scantron, pencil, your student ID, and also if you would like to bring with you a double-sided note card of notes, you are very welcome to do that this time. I'll be collecting them in at the end, and you don't have to if you don't want to. I've posted a study guide online, so have a look at that if you would like to see what will be on the final. Also, you can access all the quiz answers. Hopefully you've been doing this as you go along. But remember, you can always go back into your quizzes, look at your submissions after the quiz closes to see what you got right or wrong. So please do that. Also, I'll be available for extra office hours on Thursday. I have a meeting from 11 till 11:30, but apart from that, I'll be in my office from 9 till 12:30. So do come find me if you have any panicked last-minute questions. Does anyone have questions about the final? Yes?
Again, is that ELH 100?
Oh, I'm so sorry. It is in this room. I will change these and they will be the right one on the slides. It's trying to deal with both classes and different room assignments for things. So we are EH 1200? Okay. They all have similar names. Okay. So this is where we got to on Wednesday. Sorry about that, guys. This is where we got to on Wednesday. We said that we are already seeing sea level rise. How much sea level rise we will see by 2100 really does depend a huge amount on what we decide to do as a civilization, whether we try to cut back on carbon emissions or whether we just go ahead and burn everything. And there is a certain amount of uncertainty there. You can see that we have not that good an idea of the range of that sea level rise. And a lot of that is due to uncertainty in how much those ice sheets will be moving. Okay, just how much the dynamics of sort of that extra meltwater on Greenland, for example, might affect how much melt comes off there, or how the melting underneath the ice sheets in Western Antarctica might influence sea level rise. And just as a reminder, we're not really thinking about 2100. It's an easy cutoff date for us. But really, what we're going to decide in the next couple of decades about our carbon emissions is going to have an influence on people hundreds of years from now. Because thermal expansion of our oceans will continue for centuries, even if we stopped everything today. Our oceans are out of balance with our atmospheric warming, and so they would continue to warm. Also, we can't instantly flick a switch and melt Greenland overnight. It takes centuries, and so the additional warming we've seen recently will continue to melt Greenland for a while longer. Okay? So if we're looking towards 2200, 2300, we're seeing meters of change of sea level. And that's sort of our lower estimates. We are going to see meters of change. And so we need to start thinking about this. We know this is coming. There isn't really a scenario where sea level is decreasing or staying the same. And so we need a plan. We need to try and find ways of reducing the hazards associated with this. And we also need a way of sort of adapting to the change that we do see. So different places around the world will have different vulnerability to this. And you've hopefully, those of you who went to discussion this week, have had a bit of an introduction to this idea that how vulnerable your particular location is, your particular coastline is, will depend on things like whether it's rising out of the water or subsiding due to tectonics or groundwater removal, anything else. Okay? It will depend on, for example, how frequent you get hit by hurricanes. Miami might not be that worried about half a meter of sea level rise if that's all it was. But if we see half a meter of sea level rise and then big storms hitting with big storm surges, then they're in more trouble, and so they want to sort of think more about that. Availability of higher land. Well, so this is as basic as, is there somewhere we can move to if sea level floods our coastal areas? And that's not always the case. Availability of water resources. So we actually extract a certain amount of groundwater where there are people. And where are there lots of people? There are lots of people at the coastline. And so as sea levels rise, more of that salt water can start to sort of come inland a little bit and start poisoning our water supply. So we'll have a look at an example of that later today. How developed the coastline is. We probably won't care that much about a lot of the sea level rise along, I don't know, the northern coast of Alaska, for example, because there really isn't anyone up there. There are very few people that live along that coastline. Obviously, they care. But as sort of a country, we have to really focus our attention on perhaps our bit of coastline, where we have Huntington Beach, we have Newport Beach, these really low-lying areas with a lot of people, a lot of infrastructure that could be vulnerable if we're seeing sort of the upper sort of limits of sea level change, sort of a meter by 2100. And then lastly, how vulnerable you are will depend on how much you can pay to try and protect yourself, to try and adapt. How dependent is your population on access to that land? If you're, say, a farmer and large areas of your land are flooded, then that's your livelihood. Here, is it just a matter of building a seawall and being done with it? Okay. So all of these factors will come into play when we're talking worldwide about how vulnerable different places are to sea level rise. So The first thing that is really going to affect us if we see significant sea level rise is that we will be at increased risk of flood, and that is both from storm surge, but also just sort of regular flooding as well. So you can see on my diagram here, we have the mean sea level, the average sea level. We have the high tide on top of that. And then if we imagine a large hurricane or a large storm coming through, that drives, those winds drive water on shore, and we can get what we call a storm surge, where that sea level gradually rises over a few hours and then falls back down again. And so obviously, if you are in that house, you are not particularly happy about this situation. So if you lived in that house, what would you want to do to try and avoid being swamped by a storm surge? What is something that you could do? Move. Yes, absolutely. You could move, and that is definitely one option. But you sunk your life savings into this house. It's your favorite place to be on Earth. What could you do? Stilts is a really good one, and also build a seawall. Absolutely, you're coming up with some great answers, so it's going to go well today, I can tell. Okay, so absolutely, so we can act to try and protect that building, okay? So there's a bunch of things we can do. So first of all, some of the things that we don't often think about are actually just ensuring that the natural protection that exists along our coast in the forms of different land features, we just need to make sure that they get preserved and they get sort of kept there. So for example, sand dunes are a really good way of stopping some of these sort of storm surges and high tide waters coming inland. So if we can preserve our sand dunes, then we can perhaps protect ourselves a little better from our sea level rise. You can see here just how much this sort of bank has been built to protect these houses, and just what a good job it has been doing at that. You can see how the level of the water there is really quite high compared to the land on the other side. And so this is called a dike. It's basically just a dam that acts to protect sort of areas along rivers. Also, we call them levees in the US. Also dams, floodgates, things like that. And remember that when we see a rise in sea level, yes, our coast sees that rise, but also where rivers flow into the ocean. That river doesn't flow under sea level and then pop back up. That river level will match the sea level rise, and so we're also going to see flooding at the sides of rivers where they join our coastline, especially if we see a meter or more of sea level rise, okay? And then lastly, just land use planning. If we know that a certain area is going to be vulnerable in the next 100 years, then why don't we just stop people building there to begin with? We stop all of this heartache of some of the damage that can occur. But the problem is we have these nice sort of seawalls and this amazing connected system of levees and dams and everything else. But in extreme circumstances, even these highly engineered systems can fail. And if you imagine what would happen if that bank failed, it would be pretty catastrophic. I can't think of any example in the US, right, where this possibly could have happened at any time. No? Where did this happen? Katrina. Remember Hurricane Katrina and the flooding of New Orleans? New Orleans is, remember, really vulnerable to sea level because much of the city is already below sea level. It's been subsiding. And so they have this enormous network of levees around the rivers on either side. The problem is that when those levees failed during this enormous Hurricane Katrina, then it really very, very rapidly flooded enormous areas and did cause loss of life and a huge amount of damage. And the areas there show how much of the city was actually flooded by this. And we're talking about sort of 2, 3, 4, 5 meters of sea level rise. And this happened at the peak of the storm when people were who hadn't evacuated, were trying to shelter in their houses. And in a lot of cases, people got trapped in their homes, sort of neck deep, and very sadly died. And so highly engineered solutions are definitely a way that we're relying on sort of our coastlines being able to cope with this increase in sea level. But we have to maintain those, and that is expensive, and we have to ensure that they are really robust and able to withstand some of these events that come towards us. The other thing that's going to happen as a result of our sea level rise is that we are going to lose some of our wetlands. And that is a great shame because our wetlands are a huge source of diversity. They're really productive areas. And so you can see sort of our marshlands here, and also places like our mangrove swamps. If you haven't seen mangroves before, they tend to form in tropical environments, and they have these amazing root systems. And you can see where the high tide level is, where the bottom of the leaves are, and then the low tide level, and exposes these tree roots. And so over the next century, we might potentially lose something like 36 to 44% of coastal wetlands along the coastline of the America and elsewhere. We could lose 13% of mangrove swamps around the Pacific Islands. So we're talking enormous areas of habitat that we're losing. And this is on top of sort of the wetland destruction we're already imposing due to the fact that we like living at the coast and we've built over large areas as well. Okay? And how we manage sea level rise is also going to have a big impact. Because look what happens here if I build my wall. Okay? So if we have before, I'm not quite sure what that little creature is. It might be a frog. I can't really tell. But you can see that we have our wetlands at that sort of the boundary between our land and our ocean. And so if we just have natural sea level rise, that water floods further inland, and so those plants migrate with that sea level to further inland. And that's great. The problem is that we say, well, actually, I have a house back here that I want to protect. I'm going to build a seawall. What that does is it means that we no longer have that nice shallow area where we'd have sort of marshy plants growing, where we'd have this sort of ecosystem existing, because on one side of that wall it's too deep for those, and on the other side we've sort of blocked the access of the water. So there are certainly ways that we can try and cope with sea level rise that would allow us to preserve areas of wetlands. And again, it might be a little bit more expensive, but it might be something that we really should be considering. Increased erosion. Okay, for anyone who has seen those beautiful clifftop houses around here, then you probably care quite a lot about how much erosion is happening every year. And if we're going to see higher sea levels, we're going to expose our coastlines to increased erosion. So if you were in this house here at the top of a cliff, what would you want to do? Well, move again, but yes. What else could you do, though? What do you see along the coastlines around here sometimes? So more seawalls. What else do you sometimes see out in front? I think people are muttering it at me. Things like barriers, right? You see big boulders being dumped in front of the cliffs. Basically anything that is going to prevent those really strong waves coming through and hammering at the sort of coastline. So has anyone ever seen things like this at the beach? Yeah? So what this does is that it breaks up the power of that incoming wave. Instead of all of that wave coming in and that energy hitting this wall over here, that wave gets sort of caught in those holes, and that energy is dissipated before it hits the actual coastline. So these our coastal defenses are definitely one way. Okay. What else do they do on Newport Beach before big storms or after big storms sometimes? Who lives down there? Pile the sand up, absolutely. You've seen big diggers on the beach, right? So we can just try and preserve our beaches. Okay, so beach nourishment. So if we're losing a lot of the sand from our coastline, well, let's just add some more back. Okay, so here's an example, I think from Miami Beach quite a long time ago. It's in black and white. You can see how close at this point that seawater has got to our nice expensive hotels. And so what they did was they imported a huge amount of sand from somewhere else, and they built that beach back up to where it used to be. How long do you think that's going to last? Not long, okay? It's something that has to be done repeatedly. And so again, you have to look at really how realistic is this as a long-term solution. And certainly it might work right now when we're seeing very small rates of sea level rise. But if we're talking about, say, 1 meter by the end of the century, then that is something that, again, is quite different in terms of scale. And then lastly, well, we have these lovely, beautiful beaches and very expensive hotels that build themselves right next to the beaches. It might be time to think about better land use planning. perhaps just building further back so that those buildings, that infrastructure, those roads, whatever else you are going to be building, are less affected by sea level rise. And that's why having good numbers about what sea level rise could potentially be would be so helpful for a lot of the cities around, say, Florida, for example, where you don't have a lot of option. It's all very low lying. So let's have a look, lastly, at groundwater. Okay. So this is saltwater intrusion. So if we remember that groundwater is that sort of water that is contained within the pore spaces in our soil and our rock. Okay. And so, for example, if we lived quite near the coastline and we wanted a water supply, then what we could do is we could drill down a well and we could extract groundwater. Okay. So that's my sort of A side, my left-hand side there. And as long as we're far enough from the sea, then we should get nice fresh water. That fresh water is flowing towards the sea from sort of left to right. The problem is, as we increase sea level, you can see what happens. That shaded area is area that used to be nice fresh water. But now that that sea level has risen, it's sort of accessed further inland, we can see that now we have this sort of salt water also moving inland with that sea level. And so our nice well that used to provide us with lovely fresh water is now going to start providing us with more salty water, which we can't use for drinking, which we can't use for irrigation. And so it's sort of pushed out. So what could we do about this? Move. Well, yes. But let's think about more constructive ways of doing things. So what would you perhaps look for if you lived here? If your well is no longer good, what would you have to find? Another source of fresh water, right? You wouldn't last long without it. So you can look for alternative sources of fresh water close to the coast, or you could put your well further inland, again, whether that's sustainable or not. You can just take less water out, which also would help, because this is a problem as sea level rises. But also along the coast where we have lots of people, we have been extracting groundwater a lot. And the problem is that if you imagine I have my well in sort of that left-hand panel there, and I take out a huge amount of fresh water, that's going to suck in water from the sea. Okay? So again, if we extract too much fresh water, then we're going to sort of poison our own wells in a way by sucking in that salt water. So one way is sort of barriers to protect the fresh water at the surface at least. And we can also inject fresh water back near the coastline to basically force that seawater back. The question is if we're extracting it to drink it, what's the point of having to inject it back in to force that salt water back? And we'll show you an inventive way that Orange County is doing that. And then just, of course, finding alternative freshwater sources would be a good way of dealing with this. So, believe it or not, this is something we do. So who has been to the Orange County Groundwater Replenishment System plant? No one? One. The TAs have been, definitely. No? Oh, bad TA. Okay. So if you are an engineer, you should be going to this. It is an amazing place, and it's an amazing system. The idea is that they take sort of waste treatment water from sort of the normal sewage treatment plant. They pump it through this system, and in 45 minutes, it comes out the other side, and it's drinkable. And I've drunk it, and I'm still here. And you've probably drunk it. She's still here. Okay, it's drinkable. And the idea is that what we're doing is instead of that water just being flushed out to the sea, we can actually recycle water now to a point where it's perfectly drinkable. Psychologically, no one is willing to do this. And so what happens is that they actually take that water that's perfectly drinkable as it comes out of that plant, and they pump it back into the groundwater further upstream. And then they'll go through it and they'll extract it again and clean it again, because right now people aren't quite happy with dealing with the fact that they're drinking recycled water. It's perfectly fine. It's amazing. So they do little tours. So if you're ever free at a weekend, I think you should go visit. But one thing that we do use some of that water for is you can see on my little diagram here, I have the seawater intrusion barrier. It's sort of marked by those little black circles. And this is because we started to see seawater intrusion into our groundwater here in Orange County. So this is a complicated looking diagram. I stole this from their website. So here is sort of Orange County up here. These are our different aquifers. So these brown layers are sort of rock units which won't allow water to move through them. They're low permeability. And then we have nice high permeability, sort of high porosity areas that contain lots of water. And so here's our Pacific Ocean over here. And that green there is where seawater has been actually moving inland and starting to move into our nice freshwater groundwater sources. And we actually pump out groundwater in this area. You can see that we pump groundwater from each of these different layers in order to drink and use for agriculture. And so in order to try and stop this sort of ever sort of intruding seawater that's sort of sinking and potentially could poison our groundwater supply, then we are actually injecting freshwater, that treated freshwater, back into the ground in various places. And that sort of forms a barrier and it keeps our sort of groundwater sources clear of seawater. So it's not just something that's happening elsewhere around the world. This is actually happening now here. It's something that we're having to deal with. So it's a fascinating story if you ever get a chance to hear more. So if we are going to try and address some of these risks, we already looked at some of the things that we can do. And we can basically split our options up into 3 strategies. We can accommodate, build houses on stilts. We can protect. This is the London Thames barrier, okay, which sort of closes when there's a especially high tide, and they've had to do that a lot this winter because they've had big storms. Or we can retreat, okay? So accommodation, so basically knowing that it's going to happen and building far enough back or building high enough up that it won't affect you. Protection, we know it's happening. We're already at sea level. There's nothing we can do. So we just build barriers or sort of physically stop that sea level from affecting us. Retreat, abandonment, giving up at that point, which often is the intelligent thing to do, unfortunately. Okay? And these strategies, it's not just an earth science problem. We can say, we think this is how much sea level is going to rise due to thermal expansion, due to ice sheet melting. But at that point, it really becomes much more of an engineering challenge. And not just that, like a psychological, a social challenge, how to try and sort of allow populations to get access to this knowledge and to be able to adapt. So let's have a look at some examples. So this really is taken from your discussion, so some of you should have good answers for this. So here is an example of a city that is already feeling the impacts of sea level rise. And this is Rotterdam in the Netherlands, so Holland also it's called. So that red dot there marks where it is. And the Netherlands is a really unusual country to begin with because enormous amounts of its area already, I think anything up to 40% perhaps, is already underwater. And so in order to avoid that land flooding, they have this incredibly elaborate system of dikes and dams and floodgates and things like that that allows them to adapt to this. Okay? And so because the problem is that this is our port of Rotterdam here. Enormous amounts of shipping comes in and out of this. There's enormous amounts of infrastructure. There are lots of people. There are some very expensive facilities and buildings. And so right now, they're not likely to abandon this. Okay? It's not really going to be economically viable to just give up. Okay? So they have to protect it. And what's the thing that the Netherlands has that maybe other countries around the world don't have? Places like Tuvalu or Bangladesh, perhaps. What do these guys have that they don't? Money. Okay. And so they can afford to do a certain amount of this. Okay? So which of the strategies that we just talked about is the Netherlands likely to use? Okay, any last answers for me? Right. Yes, protection, okay? They are very unlikely to retreat at this point because that would mean that they'd have to retreat from a very large percentage of their country. And a lot of that infrastructure is along the coastlines, and they want to preserve that. So they can't really retreat. Accommodation is really difficult as well because they're already underneath sea level for large parts of their country. And so they can't really say, let it come, because they would already be flooding in that case. And so protection is really what the strategy that they've chosen, and some of the ways that they've decided to do that. So in the top left-hand side there, what they do is they build back up their beaches, that beach nourishment that we talked about. So that sort of black stuff coming out of the ship there, it isn't water, it's actually sand. So they go past along the coast and they sort of pull up sand from slightly offshore and they pile it back on their beaches again to protect those beaches. That freeway there isn't actually just a freeway going across water. This is actually built along one of these amazing dike systems that protects areas of land from flooding. I mean, you can see that these are big structures. This is sort of a huge amount of money that they have to spend, not only on building it, but then maintaining it as well. And then lastly is just a silly idea that I found, but this is the latest in sort of the fashionable housing in the Netherlands, which is that in floods, it would detach from what's sort of holding it underneath, and it would basically float with the floodwaters. And what I can't work out from the image, or I can't find out, is how they would reattach it back again when the floodwaters go down. But this is the sort of thing that they're thinking about, and especially if you've been flooded ever, you know it's a pretty miserable thing to deal with. So, accommodation in action there. Okay. So that's the Netherlands. They're in a pretty good state. They have a lot of money to invest. They have ability to do that. But if we go to other places around the world, such as Maputo in Mozambique, then you can see that we have a similar situation. We have this beautiful city built right at the coastline. It's not particularly high above sea level. And again, you can see that there's a lot of infrastructure there. You can see shipping areas, sort of big high-rise buildings. There's sort of obviously commercial activities happening along the coastline here. But the problem is that these guys are going to be much more limited in what they're able to do, because they just don't have the resources. They have an awful lot of demands on that money, and they can't necessarily spend the same amount that the Netherlands does on preserving that. And so here are some images from the BBC News website showing some of the features that you would find around this coastline. So they have built seawalls to protect certain parts of the coastline, but at a certain point, those seawalls end. And so beyond that, the land is not necessarily protected. So they've tried to protect the most valuable stuff in their city, but at a certain point on the outskirts, that protection will stop. And you can see that that protection needs constant repair because of the action of the waves. You can see it sort of eroding away behind it. You can also see areas where, even though they've tried to protect the coastline in some areas, their roadways are starting to disintegrate, and those pipes there were sewer pipes, and so obviously that's not great for if people are using the coastline for other activities, sort of swimming or potentially food. And then this lady up here, she had a little well, you can see it behind her, sort of dug for access to fresh water. And unfortunately, just because of the amount of groundwater removal that's happened there, and also rising sea levels, then that has poisoned her water supply. And so the government at least have come and built that sort of concrete block structure, which is a standpipe, which is of a new water supply. But there's a limited amount of money to spend here, and so they're going to be more vulnerable to sea level rise. Then we come to Tuvalu, or the Maldives, or any other lovely coral islands that you might have had a chance to visit around the world. Okay, so this is Tuvalu. It's a collection of little islands in the Pacific to the east of Australia. Okay, so what strategies could Tuvalu, hang on, no, wrong. Which strategy, got there eventually, could Tuvalu do to deal with sea level rise? Realistically, what is Tuvalu going to be able to do? Okay, any last answers for me? Right. Now let's see what people thought. Yeah. Okay. So it's actually really quite sad, I think. So this is sort of coming back to this idea that a lot of these islands at most are sort of 1 meter, 2.5 meters above sea level. If we're talking about an upper boundary of maybe a meter of sea level rise by the end of the century, at that point, some of these islands would become uninhabitable because that's the mean sea level, remember. That's not sort of taking into account storms and high tides and everything else. And so countries such as this could potentially cease to exist. So Tuvalu have arranged to go to New Zealand when parts of their country become uninhabitable. And Australia recently also was there in the same sort of region. They recognized a new status for refugees. So, you can have political refugees or whatever else. In this case, we have climate refugees. That is now a category that people can apply for there. Okay? And so we know that people are going to be displaced by this. And I think it's really sad that people that have lived there, this is their country, this is where their families have been for a very long time, could potentially lose their country. So really, retreat is one of the only options here. It's not realistic to start protecting this sort of area. So, little challenge for you. So I think this photo is great because I think there are some strategies here that you can see for adaptation to sea level rise or dealing with sea level rise. So I want you to take a look, speak to your neighbors. How many different sort of strategies and ways can you see that these people have tried to cope with sea level? So are there any last answers for me? I seem to be missing a few. Okay. So let's see how many examples, and I'm going to make you name them. So, right, let's take a look. So most people could find 3 at least. I think the people that are 2 are not being ambitious enough. Okay, so tell me, what is a strategy that you can see here? What have people done to try and deal with sea level change? Stilts. And what type of strategy is that? Accommodation, absolutely. So we have accommodation going on. They've tried building their house on stilts to avoid perhaps the worst of high tides. What else can you see? What else have people done? Yeah, we can see boulders in front of the house there, trying to prevent some of the erosion from waves that would happen there. What sort of strategy is that? Protection. What else? Maybe the sand. It could be that that was just a big storm which has left behind a little ridge, but it could be that they've been trying to build up the sand. And this fence here also might mean that they've been trying to preserve some of that sand and stopping it blowing inland. Okay? So again, protection. What else? I think so. How inhabited does this house look? Do you think there's anyone living in here right now? No, it's probably not a good idea, okay? It doesn't look terribly stable. So what is that? Retreat, okay? So retreat, last option really, okay? So here in just one image, we can see examples of all of those different strategies to deal with sea level change. And unfortunately, after all of your other options are exhausted, retreat is often the only one that is left to you. Okay, so the fundamental bottom line about this is we are committing the world by our greenhouse gas emissions, we are committing the world to several meters of sea level change. And our actions in the next 20, 30 years will basically say whether that's going to be sort of 5 meters or maybe at the lower end, sort of 2 or 3 meters. And that's a huge responsibility for us. Because remember, I'm 1.5 meters, okay? So we're potentially going to see at the upper level 1 meter by the end of this century. Potentially by sort of 2300, we could see 3, 4, 5. That's sort of 2, 3 of me stood on top of myself, okay? That's a huge amount of sea level rise. That's a huge number of people that are going to be affected, displaced, and really sort of put into quite nasty situations if that continues, as well as just a huge amount of money for countries to spend on dealing with this. And so I think it's really worth thinking about that. And so just sort of to pull it all together at the end, I want to show you some of the images, if it stays, that I showed you at the very, very beginning. So it seems a long time ago, right? So we have just, I hope you have gained from this class, just a sort of better understanding of the frozen parts of the Earth. I know you may not necessarily have come into contact with very much of that, apart from at least super cool water now, lots of people have seen. But it is amazing that the physics behind it, the chemistry behind it, and the way that it sort of is interconnected. We have our permafrost, our frozen soil, that is so important in terms of storing carbon and sort of providing stable surfaces in parts of our Arctic. We have our sea ice, which is disappearing so quickly that really you're going to see a huge difference if you have children and you tell them about this. And so we're potentially going to see economic benefits from the oil and gas and shipping routes there, but we'll also sort of lose beautiful, fragile bits of ecosystem. And we have our snow that affects our local areas occasionally, but mainly in Southern California, we are very worried about the snowpack in our mountains and how that is going to affect our water supplies in coming years. And then lastly, we have our big glaciers and ice sheets. And of course, our glaciers affect water supplies in the mountains, but really in terms of our ice sheets, we're talking about, say, loss of albedo, we're talking about addition of water to the oceans, and that could have a huge impact worldwide, not just in local areas. So with that, I want to say thank you very much to the TAs for their hard work. They've worked really hard this quarter. And thank you to you too. Good.